Today I would like to discuss the total basics of dimensional formulas. How can you write the dimensional formulas one after the other now? So basic dimensional formulas, let us take now. First of all, you all know that if you consider volume, okay, so how are you going to write the dimensional formula for volume here? So volume means, you all know, it is length into breadth into height. So all the three are going to be lengths only, so we can write this as L cube. And similarly we can write the dimensional formula for even area also. So area is nothing but length into breadth, okay, so that is length into breadth. We can write this as A is equal to, length is also length only and breadth is also length only, so you can write L square. Okay, so here next dimensional formula, if you consider, we can write the dimensional formula for velocity, which is very important. Okay, so velocity, so here you know velocity is nothing but displacement by time. Displacement is length and this is time. Here we can write like this. So velocity is equal to Lt power minus 1 is going to be the dimensional formula for velocity. Next, after that, let us find out the dimensional formula for acceleration. Okay, so acceleration, so dimensional formula for acceleration, you know acceleration means change in velocity by time, and velocity means displacement by time whole divided by t. So we can write this as acceleration is equal to s by t square. You know s is nothing but L, length, displacement, and this is going to be t square. So we can write the dimensional formula for acceleration as Lt power minus 2. Now the next dimensional formula we can write here is force. So what is the dimensional formula for force? So we all know that force is nothing but mass into acceleration. So we can write the dimensional formula for force as F is equal to mass is m, acceleration just now we got Lt power minus 2. Therefore we can write the dimensional formula for mass force as mLt power minus 2. Next, we can write the dimensional formula for even work also. So how can you write the dimensional formula for work? So work, we all know that work is nothing but force into displacement, and force is nothing but mass into acceleration into displacement. So we can write m Lt power minus 2 and displacement is again L. Okay, so therefore work can be written as ml square t power minus 2. So this is the dimensional formula for work. We can find out the dimensional formula for even energy also. So how can we find the dimensional formula for energy? For that, you all know that energy, let us take kinetic energy. If you want, you can write it as half mv square. You all know there is no dimensions for half. We can write here energy is equal to mass m and velocity is Lt power minus 1 whole square. So we can write the dimensional formula for energy as ml square t power minus 2. Next, now, okay, so next thing is, how can you write the dimensional formula for power? Okay, so here we all know that power is nothing but work by time. Work is nothing but force into displacement by time, which is mass into acceleration into displacement by time. So therefore mass is m, acceleration is Lt power minus 2 and displacement is L and time is t here. So power can be written as ml square t power minus 3, because this t goes to numerator becomes t power minus 3. So like this we get the dimensions of power. Now let us find out the dimensions of momentum. So how can you find out the dimensions of momentum? Dimensional formula for momentum in a simple way. So we can write the dimensional formula for momentum. Momentum P is equal to mass into velocity. P is equal to mass m, velocity is nothing but Lt power minus 1. Next, how can you find out the dimensional formula for gravitational constant? Okay, so that is gravitational constant. We all know that the formula for gravitational constant, we write g m1 m2 by r square. So to find out g, so g is nothing but f into r square by m1 m2. So F can be taken as m into a, mass into acceleration, into r square by m1 m2. Both are masses, we can cancel out here. So therefore g is nothing but acceleration is L t power minus 2, r is nothing but L square, again here m is left in the denominator. So the dimensional formula for gravitational constant is m comes to numerator become m power minus 1 L cube t power minus 2. So this is a dimensional formula for gravitation. Now let us find out the dimensional formula for angular velocity. Okay, so how can you find out the dimensional formula for angular velocity? How can you find out the dimensional formula for angular velocity omega? So the dimensional formula for angular velocity omega is nothing but 2 pi by capital T. So there is no dimensions for 2 pi, so we can write the dimensional formula as t power minus 1. Now how can you find out the dimensional formula for angular velocities or angular acceleration? Angular acceleration. So can you write the dimensional formula for angular acceleration? So the dimensional formula for angular acceleration is a is equal to alpha is equal to, we can write it as change in linear velocity by time. Okay, angular velocity by time. So that is angular acceleration is equal to angular velocity by time. So we know that angular velocity is t power minus 1, again t comes to denominator, this is going to be t power minus 2. This is a dimensional formula for angular velocity. Okay, now how can you find out the dimensional formula for angular momentum? So angular momentum L can be taken as mvr. So m angular velocity is Lt power minus 1 and this is L. So therefore the dimensional formula for angular momentum is ml square t power minus 1. Now let us find out the dimensional formula for moment of inertia. Moment of inertia. Okay, so moment of inertia, that is I. We all know that the dimensional formula for moment of inertia is I is equal to mr square, general formula. So we can write this as ml square, that's it. Now how can you find out the dimensional formula for torque? So torque, you know torque is nothing but force into perpendicular distance. Okay, so force into perpendicular distance. Therefore we can write torque is equal to force means mass into acceleration, perpendicular distance can be taken as s. So torque is nothing but m Lt power minus 2 for an acceleration, one more displacement is there, so multiply here. So this is going to be the dimensional formula for torque. Next, what is the dimensional formula for Young's modulus? You can take Young's modulus. Young's modulus, so which is given by y. So Young's modulus is nothing but stress by strain. Okay, you know that strain is a dimensionless quantity. You have to find out the dimensions of only what is said to be stress. Stress, or it can also be taken as pressure. Pressure is nothing but force by area, or stress is also going to be force by area. So this can be written as mass into acceleration by area. Area means L square. So mass into acceleration is mlt power minus 2 and this is L square. So here L square gets cancelled. So finally you'll get the dimensional formula for Young's modulus is m L power minus 1 and t power minus 2. How to find out the dimensional formula for surface tension? Okay, surface tension, it's very easy to find out the dimensional formula for surface tension. The formula is surface tension is equal to force per unit length. So force is nothing but mass into acceleration by length. Now therefore tension is equal to mass, acceleration is Lt power minus 2 divided by length. So length gets cancelled. Surface tension is m L power 0 t power minus 2. Next, we shall discuss the dimensional formula for coefficient of viscosity. Okay, so how can you find out the dimensional formula for coefficient of viscosity? It's very simple that we know the formula for F is equal to 6 pi neta r v. Okay, where r is distance, r is radius and v is velocity. 6 pi doesn't have any dimensions, therefore neta is equal to F by r into v. You know, mass into acceleration, that is ml t power minus 2 for force, and r means L, and v velocity means lt power minus 1. Therefore this gets cancelled here. Coefficient of viscosity is taken as m. This L goes to numerator, become L power minus 1. This goes to numerator, become L power plus 1, that is t power minus 1 is the final formula. Next we shall discuss the dimensional formula for intensity. Okay, so what is the dimensional formula for intensity? I. We all know that intensity is nothing but power by area, and you know power is nothing but work by time by area. Therefore the dimensional formula of work is nothing but force into displacement, which is mass into acceleration into displacement by time into area. Therefore we write I m lt power minus 2 for acceleration, this is L, and time is t here, and area can be taken as L square. So this 2 gets cancelled here. So intensity is equal to m L power 0 t power minus 2. Next we shall find out the dimensional formula for specific heat. So how can you find out the dimensional formula for specific heat? We know that quantity of heat energy is nothing but ms delta T. Okay, so we have to find out the dimensional formula for S. S is equal to energy by mass into delta T. We all know that energy can be written as half mv square. Half does not have any dimensions, mass means m, and delta T is nothing but the symbol for temperature is K. Okay, so mm gets cancelled, so therefore specific heat can be taken as, here velocity means lt power minus 1 whole square, so L square t power minus 2 divided by k. K comes to numerator, become k power minus 1. So this is the dimensional formula for specific heat. Next, my dear students, what is the dimensional formula for latent heat? Okay, so it is given by letter L. Now quantity of heat energy is nothing but m into latent heat. So latent heat is equal to energy by mass, quantity of heat energy. Energy means we can take half mv square, and mass means m. So mm gets cancelled, half does not have any dimensions. Therefore latent heat is lt power minus 1 whole square. Therefore latent heat is taken as L square t power minus 2. Okay, so this is the dimensional formula for latent heat. Next, what is the dimensional formula for gas constant? Okay, so therefore what is the dimensional formula for gas constant? Now we all know that PV is equal to nRT. So for this you have to find out the dimensional formula. R is equal to PV by N into T. We can write here P, pressure. You know, pressure can be taken as force by area. Force means mass into acceleration by area. Mass means m, acceleration is lt power minus 2 divided by L square. This gets cancelled here. So pressure means m. This L goes to numerator, become L power minus 1 t power minus 2. So we got the dimensional formula for pressure, that is ml power minus 1 t power minus 2. And volume means L cube. N means the number of moles, so dimensional formula is MOL. Temperature means Kelvin. Therefore we can write the dimensional formula for R gas constant is M, here L, L square, T power minus 2, K power minus 1, and MOL power of minus 1. This is the dimensional formula for gas constant. Next, what is the dimensional formula for Boltzmann constant? Boltzmann constant. So for that, we can take like this: PV is equal to NKT. N means Avogadro number. Okay, for number there is no dimensions, so K is equal to PV by T. So K, PV. What is PV here? P I just got here. That is K is equal to M L power minus 1 T power minus 2. V means L cube. P means K. So therefore the dimensional formula for K is equal to M L square T power minus 2 K power minus 1. Like this we can write. How to find out the dimensional formula for Stephen's constant, which is given by sigma. So here, according to Stephen, intensity is equal to sigma T power of 4, absolute temperature. And what is intensity? Intensity means power by area, which is equal to sigma T power 4. Power means energy by time into area, sigma T power 4. So sigma is equal to energy by time by area into temperature, absolute power of 4. So energy means ml square T power minus 2. This is time T. Area means L square, and temperature means K power of 4. So L square gets cancelled. Therefore the dimensional formula for sigma is M L power 0. This goes to numerator, temperature, time becomes T power minus 3 K power minus 4. So this is the dimensional formula for Stephen's constant. Now what is the dimensional formula for Wien's constant? According to Wien, wavelength is inversely proportional to absolute temperature. Okay, so wavelength is equal to B by T, where B is equal to lambda into T. B is called as Wien's constant. Therefore B, lambda is wavelength, that is length here, and T means temperature, Lk, Vn by Kelvin. Now how to find out the dimensional formula for thermal conductivity? Okay, so thermal conductivity, which is given by letter K. So according to thermal conductivity, heat energy by time is equal to K thermal conductivity A delta T divided by length. So this is the formula for thermal conductivity. Here you have to find out the dimensional formula for K. You all know energy is nothing but ml square T power minus 2. Time means again T. K. Here area means L square. So this is K, and temperature is again Kelvin K divided by length L. So L square gets cancelled. This L and here L square gets cancelled. Therefore thermal conductivity, you can take it as K, where here K is equal to M L. This T goes to numerator, becomes T power minus 3, okay, divided by this K, which comes to denominator. Therefore we can write thermal conductivity is equal to M L T power minus 3 K power minus 1. Okay. Dear students, today I would like to discuss a tough dimensional formulas for some physical quantities like resistance, magnetic field B, and also some tough dimensional formulas. Let us discuss how can you get the dimensional formula for tough physical quantities by using some general formulas. The first one is we like to find out the dimensional formula for resistance. Okay, so how can you find out the dimensional formula for resistance, which is given by letter R? The basic formula is V is equal to I into R. Okay, by using this basic formula we can find out the dimensional formula for resistance. So I can take this as R is equal to V by I. You know, potential is nothing but work done on unit charge, which is work done, which is nothing but force into displacement, mass into acceleration into displacement divided by Q. Q means I into T. I means ampere, A into T. Okay. So therefore we can find out the dimensional formula for potential, that is mass, acceleration is LT power minus 2, one more displacement is there here. Okay. So therefore one more displacement is there, so we can write L square, because S is also L only. Therefore at the denominator again A is there, so A power minus 1 comes to numerator. Here one more T is there. If it comes to the numerator, that it becomes T power minus 1. Here already minus 2 is there, we can write minus 3 here. So we got the dimensional formula for potential. So resistance is equal to potential, which is nothing but ml square T power minus 3 A power minus 1. Again I is there in the denominator. Okay, I is there the denominator, and here if you observe, this I becomes A in the denominator, it comes to the numerator, then it becomes A power minus 2. Okay, so therefore this is going to be the dimensional formula for resistance. Next to the tough dimensional formula we can find out, which is taken as inductance. So how can you find out the dimensional formula for inductance? We can use the basic formula, easiest formula, that is energy stored in inductor is given by the formula half Li square. By using this formula you can solve the problem. Okay, now let us go ahead. Let us see how we are going to get. So half does not have any dimensions. So L is equal to E by I square. Energy we can take it as half mv square, half mv square divided by A square. A means, I square. I means current. Current means we can consider ampere whole square. So A whole square. Half does not have any dimension. You know velocity means LT power minus 1. So therefore here V square is there. So M will write like that only. V square means L square T power minus 2. Okay, L square T power minus 2. Here A square comes to numerator, become A power minus 2. So this is going to be the dimensional formula for inductance. Next we'll find out the tough dimensional formula for the physical quantity, which is called as permeability. Okay, so we can write this as magnetic permeability given by letter mu naught. Okay, so mu naught you have to find out. For this we can take a simple basic formula for magnetic induction, that is B. B is taken as mu naught I by 2 into R. Is it? Yes, mu naught I by 2 into R. So how can you find out mu naught I by 2 into R? First of all, my idea is, it is better you find out the dimensional formula for B first, then it will be easy to find out the dimensional formula for mu naught. So let me do that same here. So first thing is magnetic induction B. So how can you find out the dimensional formula for B first of all? Now for that you can take the formula F is equal to BIL. Okay, it's very simple formula. From this you can derive B. It's very easy now. So B will become F by IL. You know, F is nothing but mass into acceleration, that is LT power minus 2, and I is nothing but A. Again here it is L. So LL gets cancelled. So we got the dimensional formula for B as M. L is not there, L power 0, and T power minus 2. Again A is there here, so we can write it as A power minus 1. So here, if you want to find out the dimensional formula for mu naught, so for 2 there is no dimension. Mu naught is nothing but B into R by I. So it's very simple to find out mu naught. Now B means we got just now M. Okay, L power 0, T power minus 2, A power minus 1. Again R means L. Again here A is there. So we can write the dimensional formula for mu naught in a very simple way, that is mu naught is equal to M. Here one L is there, so L T power minus 2. Here one more is there, that goes to numerator, become A power minus 2. So this is a simple strategical way to find out the tough dimensional formulas by using our general known formulas. Hope you have understood and enjoyed this. Thank you very much. Have a nice day. So how to find out the tough physical quantities here? Like for example, charge. You all know that charge is nothing but Q. So Q is equal to I into T. So what is the dimensional formula for charge? You know that I is denoted by letter Armstrong's A. So ampere A. So we can write this as Q is equal to A, and T is nothing but time. You write A into T. So this is a dimensional formula for charge. Then what is the dimensional formula for permittivity? Okay, you know the formula here, permittivity. What is the meaning of permittivity? So permittivity, which is given by letter epsilon naught. So how are you going to find out the dimensional formula for permittivity? You all know that F is equal to Q1 Q2 by 4 pi epsilon naught into R square. This is going to be our formula. Okay, so now how are you going to find out the dimensional formula for permittivity here? Okay, so now just here you have to find, there is no dimensions for 4 pi, so you can remove this 4 pi. Here epsilon naught is equal to Q1 Q2 by F into R square. That's it. By using this formula you can find out the dimensional formula for permittivity. Q1 Q2, you know Q is nothing but ampere into time. Q is equal to AT. So there are two Q's here, so we can write this as A square T square in the numerator. Force means mass into acceleration, so we write M. Acceleration is LT power minus 2, and R is nothing but the distance, which is nothing but the length here. We can take it as L square here. Okay, so now how are you going to write the dimensional formula for epsilon naught? M is there, M comes to numerator, becomes M power minus 1. Okay, so here L cube can be taken as L power minus 3 when it comes to numerator. Then here T square, T power minus 2 comes to numerator, becomes T power 4. So this can be written as T power 4. Already A square is present. So this is going to be your dimensional formula for epsilon naught, which is called as permittivity. Next, we need to find out the dimensional formula for electric field. Okay, so how are you going to find out the dimensional formula for electric field? Okay, so the dimensional formula for electric field, you know that electric field is nothing but force acting on unit charge. Okay, it is nothing but force acting on unit charge, that is F by Q. You all know F is nothing but mass into acceleration, that is M into A, and Q is nothing but ampere into time. And you also know that here E, we will write here. So E, mass means M, acceleration means LT power minus 2 divided by A into T here. So therefore electric field intensity, the dimensional formula can be written as M L. So T comes to numerator, becomes T power minus 1. Already T power minus 2 is present. We'll write it as T power minus 3 and A power minus 1. So this is the dimensional formula for electric field. So how are you going to find out the dimensional formula for electric potential? You all know that the dimensional formula for electric potential. Okay, so the dimensional formula for electric potential, you know that electric potential V, okay, is nothing but it is work done on unit charge. This is the basic formula for electric potential. You know work done is nothing but force into displacement charge. As you know, it is taken as ampere into time, because Q is equal to IT, I is equal to Q by T. Therefore electric potential can be taken as force is nothing but mass into acceleration LT power minus 2, displacement is again L, A is there and T is there. So therefore here we are going to find out the dimensional formula for V. As M you will write as usual, L square will be there, T comes to numerator, becomes T power minus 1, already T power minus 2 is present, so we will write it as T power minus 3 and A power minus 1. This is going to be the dimensional formula for electric potential. Okay, so now we need to find out the dimensional formula for capacitance. How are you going to find out the dimensional formula for capacitance? So it's very simple. Okay, so you will take in a capacitance here. So you all know that Q is equal to CV, and you have to find out the dimensional formula for C. C is nothing but Q by V. Q is nothing but I into T, which is ampere into time, and V is nothing but, or else you can write like this also. We will write Q by V here, Q, and V is nothing but, what is V actually? Work done on unit charge, so W by Q. So Q comes to numerator, becomes Q square by W, and therefore the formula for capacitance can be taken as C is equal to Q square. Q square means nothing but A square T square, and work done is nothing but force into displacement. Force is nothing but mass into acceleration into displacement, that is L square here again. So M comes to numerator, becomes M power minus 1, L power minus 2, okay, and T power minus 4 when it comes to numerator, T power 4, you can write T power 4 and A square. This is going to be the dimensional formula for capacitance. Hope you have understood this problem. Thank you very much. Have a nice day.